Hello students, welcome to LynxE. In this video, we are going to talk about photodiode. How photodiode works. See, photodiode is nothing but what? It converts a light energy to electrical energy. That means you should understand that whenever there will be a fall of light on a diode, it will convert it into electrical energy. That means it is designed in such a way, it is designed in such a way that when a fall of light enters in the depletion region of a PN junction diode, it reacts. It converts into electrical energy. Okay, so that is the main point. Now, second is nothing but, so as I told, it reacts when light falls on it. The most important point is what? It works in a reverse bias, right? It works in a reverse bias. So it is a PN junction diode, okay? But when there will be energy fall, a light energy falls in a depletion region, it reacts. Let's make a PN junction diode first. So I can say this is nothing but of region. So you should know that this is depletion region, right? Okay, where this is P, this is N. So this would be having holes as a majority carriers. It will be having electrons as a majority carriers. The minority carriers will be electrons here, and the majority carriers will be, minority carriers will be holes here. So as I told you, this diode works in a reverse bias. So what is the meaning of a reverse bias? Reverse bias is nothing but where we connect a P to negative terminal and a positive terminal is connected to the N region. Okay. So we are applying some reverse voltage. So you should understand that students, whenever we are applying a reverse voltage, that means what? P is connected to the negative and N is connected to the positive. And we know that in reverse junction diode, the diode don't work. That means there is no conduction. But still, there is a minute current, that is microampere current, flows in the circuit, right? A microampere current flows in the circuit due to the minority carriers. Okay. So what happens as it is connected to the negative terminal? So the electrons from here will be repelled and they will cross the junction. They will basically cross the junction and it enters into the N region. Okay. Okay. In a normal PN junction diode, if this is nothing but a depletion region, so what it is depleted with? This is nothing but depleted with the ions. It has a positive ions in this, and this will be having a negative ions, right? So this is my depletion region. Okay. And as I told you, a minute current flows in the circuit when we apply a reverse voltage, right? So that is negligible current. So till now, what I am saying, see, in photodiode, what we will be doing, we will be basically giving a light in a depletion region. So this is nothing but what I can say energy. That is nothing but a photon what I am giving, right? That is, I can say, let's write in a simple way, that is light. So when I'm giving a light in the depletion region, what will happen? So before that, we will understand that, see, as I'm applying a negative voltage with a negative current, right? So if light is not applied, that means I can say your intensity is zero, right? There is no light on the depletion region. So at that case, a minute current flows and have that made in VI characteristics. So that is nothing but something like this, right? This is nothing but what I can say. Suppose I say my intensity is zero. So this is my current. And this current is also known as dark current. So simple, we can understand no intensity. If there is no intensity, that means the current what it is flowing in the diode is a dark current. Okay, so now understand further what happens. So student, now what happens? So now when we say that a light falls in the depletion region, the ample amount of a photon energy is falling on the depletion region. So what will happen? An electron hole pair, a couple of an electron hole will be produced in this depletion region. So what happens? As it arises, it basically your depletion region is having the absorption of a light. So the charges from here will move out from the junction and the barriers start getting reduced. As you increase the reverse voltage, as well as you increase the intensity. So what we can say, more and more electron pair will be generating in a depletion region, and the barrier potential, that is depletion region, will not exist. If a depletion region is not existing, that means the conduction will start. So I can say when you are increasing the intensity, the current will increase. So let's say when you are increasing the intensity, so let's consider that at one intensity at I1, you are getting some current, right? So this was a current which is dark current. This is the current which I have got at I1. If you increase more intensity, again current will increase. So this will be one value of a current at intensity I2. And in this way, we can say photodiode works. Now, student, you have to understand that where exactly photodiode is used. Okay. And what are the applications? See, photodiode is nothing but what? It is made up of such a case. So photodiode has such a case that it has a glass, it has an opening for a light, right? So we should understand that where it is used. It is used in a burglar alarm, right? So suppose, for example, if a thief comes, nearer to a locker and there is a dark light, it's suppose he uses a light or a torch or something. So what will happen as soon as he owns any light? So what will happen? This circuit will work. If this circuit will work, that means what? Electrical signal is produced. What will be used? We further use a microcontroller or a microprocessor, or there will be a system who will be detecting that electric signal and an alarm will raise, right? So that is very useful. That was just a one application what I told of a photodiode. There are n number of applications for a photodiode, but the most important is what we understood, that it is basically light. Whenever input is a light and the conversion is nothing but into a electrical energy, it converts a light energy to a electrical energy. Hope you are clear with this and you understood the working for a photodiode. Thanks for watching my
To know more, sign up to www.lynxe.in.